You manage an application using Amazon DynamoDB as the database. Your business requires a multi-region disaster recovery solution with active-active replication to ensure low-latency reads and writes globally. Options: A. Use DynamoDB global tables. B. Use DynamoDB streams with Lambda to replicate data to another region. C. Use AWS DMS to replicate data between DynamoDB tables in different regions. D. Use S3 cross-region replication to store the data from DynamoDB tables. Correct answer: A. Use DynamoDB global tables. Explanation: DynamoDB global tables provide a fully managed, multi-region, and active-active replication solution, ensuring low-latency reads/writes. Why not other options? Option B. DynamoDB streams with Lambda requires custom code and doesn't provide true active-active replication. Option C. AWS DMS isn't designed for real-time replication with active-active requirements. Option D. S3 cross-region replication doesn't apply to DynamoDB use cases and won't ensure consistency. You have a monolithic application hosted on EC2 instances and want to migrate to a microservices architecture. The migration should minimize downtime and provide an easy way to manage the lifecycle of microservices. Options: A. Use AWS Elastic Beanstalk to host microservices. B. Use Amazon ECS with EC2 launch type. C. Use Amazon EKS with Fargate. D. Use AWS Lambda with API Gateway. Correct answer: C. Use Amazon EKS with Fargate. Explanation: EKS, Elastic Kubernetes Service, with Fargate provides a scalable, containerized platform to manage microservices without managing servers. Why not other options? Option A. Elastic Beanstalk is not ideal for fine-grained microservice deployments. Option B. ECS with EC2 launch type requires you to manage the EC2 instances. Option D. Lambda with API Gateway works for serverless microservices, but may not be ideal for migrating large monolithic applications. Your organization must archive 10 terabytes of financial data for compliance purposes. The data will rarely be accessed, but must be retained for 10 years at the lowest cost. Options: A. Store data in S3 standard with versioning enabled. B. Use S3 Glacier Deep Archive. C. Use Amazon EFS with lifecycle policies. D. Use RDS to store the data in a database. Correct answer: B. Use S3 Glacier Deep Archive. Explanation: S3 Glacier Deep Archive is the most cost-effective solution for long-term, rarely accessed data. Why not other options? Option A. S3 standard is too expensive for archival storage. Option C. EFS is designed for file system use cases, not archival storage. Option D. RDS is costly and unnecessary for data that is rarely queried. You are running a web application on EC2 instances behind an application load balancer. The traffic to the application is spiky, with unpredictable peaks. Options: A. Use reserved instances for the EC2 instances. B. Use spot instances with auto scaling. C. Use on-demand instances with auto scaling. D. Use auto scaling with a mix of on-demand and spot instances. Correct answer: D. Use auto scaling with a mix of on-demand and spot instances. Explanation: a mix of on-demand and spot instances ensures cost savings while maintaining availability during traffic spikes. Why not other options? Option A. Reserved instances don't provide flexibility for spiky workloads. Option B. Spot instances alone may lead to interruptions during high demand. Option C. On-demand instances are costlier without leveraging spot instances. You are storing sensitive customer data in Amazon RDS. The company requires encryption for all data at rest, including backups and snapshots. Options: A. Enable RDS encryption at the database level during instance creation. B. Use AWS KMS to encrypt the EBS volumes attached to the RDS instance. C. Use SSL/TLS to encrypt connections to the database. D. Use AWS Cloud HSM to encrypt the RDS instance. Correct answer, A. Enable RDS encryption at the database level during instance creation. Explanation: RDS encryption at the database level ensures that all data, including backups and snapshots, is encrypted automatically. Why not other options? Option B. KMS encryption of EBS volumes doesn't cover RDS backups and snapshots. Option C. SSL/TLS encrypts data in transit, not at rest. Option D. Cloud HSM is more complex and unnecessary for RDS encryption use cases. You manage multiple AWS accounts for your organization and need a centralized solution to enforce IAM permissions across all accounts. Options: A. Use AWS organizations with SCPs, service control policies. B. Create separate IAM users in each account and assign policies. C. Use AWS IAM Identity Center, AWS Single Sign-On. D. Use cross-account IAM roles for each account. Correct answer, A. Use AWS organizations with SCPs, service control policies. Explanation: AWS organizations with SCPs allow centralized control over permissions across multiple accounts. Why not other options? Option B. Managing IAM users separately in each account increases complexity. Option C. IAM Identity Center is suitable for single sign-on but not for enforcing SCPs. Option D. Cross-account roles don't provide centralized policy enforcement. You need to process real-time data streams from IoT devices, generating millions of events per second. The solution must scale automatically and handle failures. Options: A. Use Amazon Kinesis data streams with AWS Lambda. B. Use SQS with EC2 instances for processing. C. Use DynamoDB streams for real-time data ingestion. D. Use Amazon EMR for processing the streams. Correct answer: A. Use Amazon Kinesis data streams with AWS Lambda. Explanation: Kinesis data streams handles real-time, high-throughput data ingestion, and Lambda ensures serverless, fault-tolerant processing. Why not other options? Option B. SQS doesn't support real-time streaming data. Option C. DynamoDB streams is not designed for high-throughput ingestion. Option D. EMR is optimized for batch processing, not real-time streams. Your organization stores log data in Amazon S3 in various formats: CSV, JSON, Parquet. The team needs to run SQL queries directly on this data without moving it, while keeping costs low. Options: A. Use AWS Glue to transform the data and store it in an RDS instance. B. Use Amazon EMR with Spark to query the data. C. Use Amazon Athena to query the data directly from S3. D. Use Redshift Spectrum to query the data. Correct answer: C. Use Amazon Athena to query the data directly from S3. Explanation: Athena is a serverless, pay-per-query service specifically designed to query structured or unstructured data stored in S3. Why not other options? Option A. AWS Glue is for ETL and not optimal for querying data directly. Option B. Amazon EMR is costlier and more complex for ad hoc queries. Option D. Redshift Spectrum requires provisioning a Redshift cluster, which adds unnecessary cost. You are running containerized applications on Amazon ECS using the Fargate launch type. The containers need shared storage to persist state across multiple tasks. Options: A. Use Amazon S3 to store shared data. B. Use Amazon EFS as a shared file system. C. Use instant store volumes. D. Use DynamoDB for storing shared state. Correct answer: B. Use Amazon EFS as a shared file system. Explanation: Amazon EFS provides a managed, scalable file system that is ideal for shared storage across ECS tasks. Why not other options? Option A. S3 doesn't support file system semantics required by shared storage. Option C. Instant store volumes are ephemeral and don't persist data across tasks. Option D. DynamoDB is designed for structured data, not file storage. You have a public-facing web application hosted on EC2 instances. The application needs protection from DDoS attacks and must allow only HTTPS traffic. Options: A. Use Network Load Balancer with AWS Shield Advanced. B. Use CloudFront with AWS WAF and AWS Shield Standard. C. Use an application load balancer with security groups. D. Use Route 53 with a custom DNS firewall. Correct answer: B. Use CloudFront with AWS WAF and AWS Shield Standard. Explanation: CloudFront distributes traffic globally, reducing the attack surface. AWS WAF provides Layer 7 filtering, and Shield Standard offers basic DDoS protection. Why not other options? Option A. Network Load Balancer doesn't provide Layer 7 filtering or DDoS mitigation. Option C. Security groups don't protect against DDoS attacks. Option D. Route 53 DNS firewalls are not designed for application layer protection.